This independent educational video is not endorsed by Burj Khalifa or MR. All visuals are AI generated for illustration only.
In the middle of this silent desert, Burj Khalifa building making will attempt the impossible.
From a few fragile lines in the sand, Burj Khalifa building making begins its first step.
Before the day's work begins, she's responsible for every decision that keeps this extreme project running safely and on schedule.
Every millimeter matters, because Burj Khalifa building making cannot afford to be even slightly off.
These tiny markers will carry the weight of the tallest dream in Burj Khalifa building making. Before steel and glass, Burj Khalifa building making is just human hands pushing back against the desert.
Around this table, Burj Khalifa building making is reduced to lines and numbers, but the risk behind them is enormous.
Every line of light locks the future spine of Burj Khalifa building making into position.
Even before a single floor exists, Burj Khalifa building making is already racing against time, heat, and gravity.
Tonight, this quiet rectangle becomes the operating theater for Burj Khalifa building making.
The first bite into the earth marks the physical birth of Burj Khalifa building making.
To keep standing, Burj Khalifa building making must go down before it can go up.
Beneath the future lobby, Burj Khalifa building making carves out a hidden world of foundations. Every layer of soil must be understood, because Burj Khalifa building making depends on what no one will ever see. This perfectly carved box is the cradle where Burj Khalifa building making will grow its roots.
Water is the invisible enemy, so Burj Khalifa building making starts by shielding its heart from below.
Every hidden seam they seal protects decades of life inside Burj Khalifa building making.
From this line forward, Burj Khalifa building making enters a realm where mistakes are not allowed.
To anchor a vertical city, Burj Khalifa building making calls in machines designed to drill deeper than buildings are tall. Each rig becomes a surgeon, cutting narrow shafts that will hold the weight of Burj Khalifa building making.
Before a single crane moves today, every worker in this crew needs to know exactly how close we are to the edge of disaster.
Hole after hole, Burj Khalifa building making bites into the earth to anchor itself to the bedrock.
Each of these shafts in Burj Khalifa building making dives more than 50 meters, deeper than many towers are tall.
Before concrete touches the ground, Burj Khalifa building making bends thousands of steel bars by hand. Together, this forest of piles becomes the underground skeleton of Burj Khalifa building making.
No visitor will ever see this steel, but Burj Khalifa building making will depend on it for a lifetime.
Each cage sinks into the earth as a steel spine, bracing every future movement of Burj Khalifa building making. From above, it looks simple. Hidden below, Burj Khalifa building making is already massive.
Engineers measure every second, because the wrong mix or temperature could cripple Burj Khalifa building making before it rises.
Now steel and stone finally meet, forming the first permanent bond in Burj Khalifa building making. By the time the sun rises again, Burj Khalifa building making already holds on.
Pile by pile, invisible columns lock into place, strengthening the base of Burj Khalifa building making.
Tonight, the entire foundation will be filled in one relentless operation. Hundreds of loads arrive on a strict schedule, each one part of a single gigantic slab.
From the surface, high-pressure pumps drive the concrete deep into the waiting steel skeleton. The mix is engineered to remain workable, yet strong enough to carry unimaginable weight.
Every morning starts here, with with her walking the team through the plan that keeps people safe and the build moving higher.
Vibrating the concrete drives out trapped air, turning a fragile slurry into solid stone. Lasers confirm that every point sits at the exact elevation demanded by the design. Hour after hour, the empty pit disappears beneath a 4-meter-thick layer of high-strength concrete.
Different teams attack different zones at once to keep the pour continuous and uniform.
Inside, the concrete heats itself as it hardens, so engineers monitor every degree.
Cooling pipes carry chilled water through the foundation, preventing cracks that could compromise the entire structure. By dawn, the liquid river has become a single monolithic platform ready for the tower above.
Survey teams confirm that the completed raft still aligns perfectly with the original markers. Next, towering cranes rise to serve as the arms of the build, feeding materials to every level.
These cranes will climb with the structure, always just above the highest floor.
Around the future elevator shafts, a moving mold is built to shape the central concrete core.
This formwork will never come down, and it will climb higher each time a new level is cast.
Inside the mold, steel bars weave into walls thick enough to resist wind forces at extreme height.
Fresh concrete flows in, locking around the steel and forming the tower's rigid spine.
Once the mix has hardened, hydraulic jacks lift the entire system up one floor, ready to repeat.
As the cycles stack up, a solid concrete shaft begins to rise above the desert.
Workers now operate dozens of meters above the slab, exposed to heat, wind, and height.
They constantly check that every wall stays perfectly vertical, or the tower will lean long before it's complete.
Each cured layer records another step in the tower's long climb to the sky. From the spine, new floors branch outward, starting to hint at the tower's final footprint. Below each new slab, temporary supports carry the weight until the concrete is strong enough to stand alone.
These bare surfaces will one day be polished lobbies and hotel suites, but for now, they're just raw structure.
What you see from the street is just glass and steel, and this is the briefing, where workers learn the real tricks that keep the tower standing.
To passers-by, the project is only a strange new shape appearing above the hoardings.
Up close, the build is a vertical factory, with teams stationed at every elevation.
On a normal calendar, months pass. On the skyline, the tower seems to leap upward overnight.
Soon, this concrete column will surpass ordinary skyscrapers, and the real challenge will only just begin. From above, the tower's true geometry appears. 3 wings anchored to a single central core.
This triaxial layout is not just beautiful, it is engineered to tame the desert winds.
Each wing braces the others, turning the tower into a single locked-together unit. Concrete walls extend outward like rigid corridors, channeling forces back into the core.
Inside the floor slabs, high-strength steel tendons will be tensioned to pull the structure tight. By stretching the tendons, engineers preload the concrete so it can resist enormous bending forces.
As the tower rises, the wings shorten step by step, sculpting its tapered silhouette.
At every setback, floor plates shrink, reducing wind load and lightening the upper structure.
At this stage, floors resemble open skeletons, waiting for their skin and organs.
To protect the tower from Dubai's heat, An advanted curtain wall system is assembled on the ground.
Each panel is double-layer glass with a reflective coating, tuned to block much of the desert sun. Specialist teams verify that every panel matches exact tolerances before it leaves the ground. Thickened edges and walls at these transitions absorb the extra forces at each change in shape.
Seen from a distance, the setbacks create a spiral, breaking up wind vortices that could make the tower sway.
While the core continues climbing, the slabs and walls race to follow behind it. Special mixes are designed to flow easily, yet cure to strengths far above ordinary concrete.
Panels weighing hundreds of kilos are hoisted hundreds of meters into the air.
Working from hanging platforms, crews align each unit with anchors embedded in the structure. Behind the polished exterior, hidden brackets and seals keep out wind, sand, and rain.
The facade combines glass, aluminum, and stainless steel into a shimmering vertical shell.
Cladding starts near the base and chases the structure as it climbs, always several floors behind.
Hidden corridors let maintenance crews access the facade years after construction ends. On the roof, custom machines stand ready to clean and inspect the exterior at extreme height. These devices extend like mechanical spiders, carrying workers along the tower's sides.
Today's briefing isn't about a normal job. This team is preparing to build the next piece of the tallest structure on Earth. From this perspective, the building is so tall that even maintenance becomes an engineering feat. As day ends, the structure now appears half-dressed, half-skeleton.
Multiple teams work in parallel, compressing a decade of effort into just a few intense years.
Workers are among the first to see the view that future residents and visitors will enjoy.
The tower has now surpassed ordinary skyscrapers, but the climb toward its final height is far from over.
Over time, the gray structure vanishes behind a continuous wrap of glass and metal.
The concrete shaft has now climbed beyond the height of many complete towers.
From a distance, the repetition looks simple, but every level is slightly different.
As the tower rises, the concrete and steel are upgraded to handle increasing loads. Special mechanical levels tie perimeter columns into the spine, stiffening the entire structure. With each new level, the drop grows more terrifying for crews who work at the edges.
Wind conditions are constantly tracked because gusts can halt lifting and pouring in seconds.
At the base, a custom pumping system is assembled to push concrete higher than ever before. Reinforced steel pipes carry the mix through a vertical maze hundreds of meters long.
Pressures approach 200 bars, enough to shatter ordinary equipment. At the top, the mix finally emerges to feed the core walls and upper slabs.
The climbing form and cranes repeatedly leap upward, never touching the ground again.
Long before completion, the structure already surpasses every nearby landmark. Temporary walkways and platforms must be rebuilt over and over as the shape changes. Safety systems are upgraded at each stage because a single slip here could be fatal.
Half of the tower shines like a completed skyscraper, while the rest still looks like an exposed skeleton.
Mechanical floors double as structural rings, distributing loads and housing vital equipment. Here, steel outriggers act like braces, binding distant columns into one system.
Even as night falls, the structure remains alive with crews and machinery.
Near the top, segments of a hollow steel spire wait to complete the tower's profile.
Constructed from heavy welded steel, the spire houses communication equipment and access ladders.
Sections are first assembled inside the tower, protected from wind and weather. Hydraulic jacks will later drive this steel spear up through the top of the building. The core conceals a shaft reserved for the final extension that pushes the tower to its record.
Above a certain level, steel replaces concrete to reduce weight and speed assembly.
At this altitude, assembling steel is a delicate balance between precision and exposure. The tower now tapers to a narrow stem, its final outline almost complete.
Deep inside, crews install pumps, tanks, and valves that will feed water and air to every floor. Red vertical risers carry firefighting water, ready to activate if any floor is threatened. Electrical risers form the building's nervous system, distributing power to lights, elevators, and cooling. The tower is closing in on its final height, but the most delicate lifts and interior work are still to come.
At the summit, only a narrow framework and the unfinished crown remain.
Engineers prepare for a sequence of lifts unlike anything attempted on this scale before. The steel pipe that will complete the tower is assembled safely inside the structure. Hydraulic jacks grip steel strands and will pull the spire upward in careful stages.
Cycle by cycle, the steel core inches toward the open sky at the very top. Eventually, the hidden pipe breaks through the roof and becomes visible above the crown.
Roller guides keep the steel centered as it climbs, preventing dangerous contact with the structure. After each lift, measurements confirm the new height before the next cycle begins.
For the first time, the tower stands at its full height, 828 meters above the desert. Outside, the city watches the tower stretch further beyond anything built before. With the structure complete, engineers turn inward to bring air, water, and power to every level.
Decorative fins wrap around the pipe, completing the spiral that the setbacks began.
Massive fans push cooled air through the tower, allowing life at heights where outside temperatures can be extreme. Chilled water circulates through insulated pipes, feeding air conditioning units across hundreds of floors.
Intermediate reservoirs store water at height, reducing the pressure needed to reach upper levels. Dedicated fire systems stand ready to deliver water to any floor within minutes. Electrical rooms at key levels distribute power through a network of risers and cables.
Data lines form the digital nervous system, connecting sensors, controls, and communications. From a central control room, operators oversee every pump, fan, elevator, and alarm in real time.
Vertical shafts become high-speed highways, carrying people at up to 10 meters per second. Double-deck elevators move thousands of visitors every hour between stacked lobby levels.
In less than a minute, passengers travel from ground level to observation decks, more than 400 meters up.
Behind full-of-height glass walls, visitors can see the city, the sea, and the desert stretching to the horizon. On higher terraces, guests feel the wind directly, an experience some find thrilling and others terrifying.
For many, the tower is their first encounter with this scale of engineering.
At ground level, visitors wait beside a man-made lake for the evening's first show.
Jets of water shoot up to 150 meters, choreographed to music and light.
After dark, the building becomes a giant screen, its facade animated by LEDs and lasers.
Fountains, music, and light shows turn the tower into the centerpiece of an entire district. From a handful of lines in the sand to a living vertical city, this is how the world's tallest building was made.